All right, welcome back, everyone. It's the architecture track. Good morning, good afternoon, good evening. We're on the home stretch, but we still have hours of fantastic content yet in front of us. So don't leave yet. Grab a snack, grab some more coffee if you need it. Or, if it's evening, go ahead, have a glass of wine, have a cocktail, whatever makes you happy. No judgment here. So, up next, we have my friend Michael from Dynatrace. He's going to talk to us ultimately about how to use Minecraft. I should probably show my son this session. Just yesterday, he was showing me a room that he had built in Minecraft, and it's interesting to see the stuff that he comes up with. He was explaining a lot of terms to me that I admit I didn't understand because I'm not a 13-year-old boy, but that's okay. So without further ado, I'm going to turn it over to Michael, who will talk to us about replatforming our legacy apps. Michael, take it away, buddy.
All right. Thanks, Nate. Hopefully everybody can hear me okay. I actually lost the tail end of Nate's audio there. So hopefully everything is okay. I wanted to thank Nate as the chair of the architecture track and my friends at the Now Tanzu team for allowing me to come here and talk about this today. I am not 13 years old. However, I still play Minecraft on a pretty regular basis. And some of the things that I'll be getting into today are going to actually talk about some of the interesting things that happen when you are running modded Minecraft. So just a kind of brief overview of the agenda here. I'm going to talk a little bit about why Minecraft is an interesting example for choosing an application to port to something like Kubernetes. I'm going to actually walk you through the story of my modernization efforts here because they might mirror some of the things that you've seen inside of your organizations and your efforts around modernization. And then I'm going to spend the bulk of the time kind of talking about moving this application to TKG, that's Tanzu Kubernetes Grid. And then at the end, I'm going to close with some final thoughts. And honestly, the final thoughts can almost be a talk in and of themselves. I'm going to kind of walk through some of the interesting things I've experienced around trying to build an upgraded home lab while the world is in the midst of a pandemic. So why Minecraft as an example for replatforming? So Minecraft is Java-based, but it's closed source. So what that means is, since it is Java, we're going to be able to peek under the covers a little bit, possibly, decompile some of the classes if necessary. It's going to be relatively easy to reason with when it comes to kind of understanding some of the things that are happening under the covers. But Minecraft in and of itself is really architected in the worst possible way for being a multiplayer environment running on new stack technologies like Kubernetes. Everything that happens in Minecraft is actually happening in the context of a single threaded tick. That tick is something that has to occur in 50 milliseconds or less across all the players on the server. And if that tick runs over, subsequent ticks will be straight up skipped. So what that means is, if I'm running modded Minecraft and I've got a bunch of other crazy machines in here, you'll see my screenshots there. I have a nuclear reactor. I have a steam turbine. I have crazy machines that are turning crystals into energy. All of that stuff needs to happen in a certain amount of time, or else your user experience as a player will be really, really terrible. And Minecraft has some pretty significant persistent disk requirements. So it's almost more analogous to a database in that way. So, talking about my early steps towards modernization, right? The first thing I did, as most folks would normally do, is I took to isolate my Minecraft workload on a virtual machine. I built a new file server for my house that was running ZFS. This was 2013, so SSDs were still way too expensive for this kind of thing. But I did actually end up using a real legit Xeon CPU so that I could take advantage of ECC registered memory and so on, right? And this worked out really well, except it just wasn't fast enough. Once I started to get additional players on my server, I started to get a lot of skipped ticks. All right, and that little message there actually shows that almost 24 seconds of player activity was skipped and did not take place in the server, right? So the next thing that I look to do is I look to take my Minecraft environment and port that over to Docker. By moving that to Docker, it allowed me to run that at near bare metal performance. There is a little bit of Docker overhead, arguably, if you go on the internet and so on, folks will kind of argue about that ad nauseum. It was sort of isolated from the underlying operating system. Docker is not nearly as isolated as people think it is, but it is pretty isolated from the underlying operating system. And then this allowed me to easily give access to that environment, to the varying types of storage that I had in my server. So I had both fast storage on SSD, because I was able to procure some SSDs over a period of time for that. And then I had the slower ZFS-based storage that I could use for backups. So again, that allowed me to really easily kind of provision access to those different types of storage for this environment, because those different types of storage had different needs. And don't mind that Docker run example. It's really old, circa 2014 or so, well before we had volumes in Docker. So my start command was still talking about bind mounts. But since I was running in Docker, I wanted to kind of see what was going on under the covers inside of Minecraft. So I wanted to, kind of, again, introspect what's happening inside of that JVM, understand the CPU behavior there. I found that in my server, basically, again, single-threaded, not surprisingly, consumed 6 to 8% of the overall CPU in the host, basically just running on pegging a single core at nearly all times. But modded Minecraft is a crazy, insane memory hog. It'll use almost as much memory as you give it. And that can actually cause us some interesting concerns as we start to talk about Kubernetes a little later. But we really needed to then understand what's happening in that tick. So by utilizing the tooling that I have access to, because obviously I work for Dynatrace, so I threw Dynatrace at Minecraft, I took a look at some CPU analysis, right? So started to take a look at method hotspots. And this is kind of telling me, which methods inside of that JVM are consuming the most CPU. And this allowed me to kind of see that a lot of CPU was taken by this crazy function name, func_71217p. All right. Now, the interesting thing about Minecraft is because it's written in Java, and because folks could kind of easily decompile that if necessary, a lot of what's actually happening is obfuscated. You end up with all these crazy method names. You end up with these crazy function names and so on. Sometimes you can actually reason with things. Obviously, dedicated server underscore func71190q. Like, you can sort of kind of understand that has something to do with the actual server functionality. But luckily, since, again, Minecraft being Java-based, there's a very active modding community around it. And it's actually why a lot of educational programs utilize Minecraft as an example to teach folks Java. The MCP actually gives you a kind of lookup table as a CSV with all the function names turned into a real name and a little bit of description of what that function is. So based on this, I'm able to find out that this function that's consuming quite a bit of CPU time is actually the main tick thread. So what this means now is I can take with Dynatrace, Dynatrace being an APM tool, we're normally focused on things that talk HTTP, right? We're normally focusing on things that somebody clicks on something in a website and something happens under the covers in order to turn that, in order to enact some change in a UI, right? But since we don't speak HTTP here, the existing functionality for automatically detecting services and things like that, it's not going to find anything. It's going to find everything that my JVM is talking to that's speaking HTTP, but it's not going to actually instrument this master tick thread. So utilizing Dynatrace actually makes it really super easy for me to just kind of browse all of the classes and methods on the server. I'm able to pick my entry point, and I'm able to tell Dynatrace to call to create a transaction, a pure path, every time that the master tick thread is called, right? And that basically allows me to monitor that. I'm able to track throughput of that transaction. I'm also able to monitor the response time, right? And I'm able to monitor outliers. I'm able to kind of dig under the covers and find out if a certain part of the mod pack is causing trouble. It's really kind of the fundamental piece of kind of tracking what's happening throughout this process, right? So now I've kind of figured out what's happening under the covers, and I'm going to take and I'm going to migrate this modded Minecraft instance. I'm going to migrate it to TKG. So my initial performance goals, this all really kind of started as a great, quarantine project, right? We're not allowed to go anywhere. We're not allowed to see our friends. We're not allowed to go to in-person conferences anymore. So I thought this was a great kind of excuse to, upgrade that vintage 2013 Xeon that I have in the basement and move to something a little bit more modern. I also wanted to really kind of take a look at some of the new AMD hardware that was kind of lighting up the newswire at the time. So I needed something that had a lot of threads, right? But since Minecraft is single threaded, I actually needed pretty good IPC, that's instructions per core. I needed a server that was going to have fast single threaded performance, but also allow me the scalability that I need in order to possibly run other workloads in this environment as well. These screenshots here are actually quite old. Now I've actually gotten to the point where even though I have 384 gigs of RAM across this cluster, I've only got 5 gigs of RAM free. So I'm going to have to procure some additional memory as time moves forward here. But and I also wanted to really address storage needs and use this as a kind of way to get my feet wet with hyperconverged infrastructure, right? So this was an opportunity to build out an all-flash vSAN. I actually consulted the HCL. I was able to find some used Intel P4610 U2 SSDs on eBay. But the capacity tier for vSAN is something that's not on the HCL, so I'm not going to call it out here. And it was also an opportunity for me to upgrade my networking. Obviously, vSAN really wants the interconnect between the nodes to be really fast. And again, once I got this, really awesome, vSAN-based vSphere environment up and running, I needed to start digging into Kubernetes, right? And I need to start thinking about, well, how the heck do I have access to all this different type of storage in Kubernetes? And that's where we start to think about some of the interesting things that are happening in the overall Kubernetes ecosystem right now. So every Kubernetes environment requires something called the CPI. That's the Cloud Provider Interface. The Cloud Provider Interface, for folks like me that have been working with Bosch for a long period of time, the CPI made a lot of sense to me. It's basically the interface between Kubernetes and whatever IaaS we happen to have under the covers, right? In this case, obviously, it's vSphere, but for other folks, it might be Google, it might be Amazon, and it might be Azure. But now this crazy thing is happening in the overall Kubernetes ecosystem. We have this concept of an in-tree CPI and an out-of-tree CPI. Now, the in-tree CPI is what is part of the core Kubernetes codebase. And it was or is maintained by that Kubernetes team, and it's subject to the release cycle of Kubernetes itself. So some of the vendors found that to be kind of insufficient for them. So now we have this concept of an out-of-tree CPI. In this case, VMware is responsible for their own CPI. They're allowed to release that with their own cadence. And they're able to kind of keep that updated and take advantage of new functionality quicker. Then we also have the container storage interface, right? So the container storage interface is how the underlying Kubernetes subsystem is going to integrate with our storage subsystem. So you might have, in this case, a CSI for vSphere. And this is how the underlying orchestrator mounts storage to the given cluster nodes, right? In this case, the new vSphere CSI requires us to have the out-of-tree CPI. And one of the really cool things that I found with this, given that I've been working with the various Tanzu flavors of Kubernetes for quite some time, I have been working with TKGI for a really long amount of time, but it turns out that TKG itself, it deploys and configures the CPI and the CSI out of the box. So once you've actually done that deployment, all these things just work, and you don't have to mess about trying to deploy the CPI or the CSI yourself. So as we start to think about all these different types of ways to access our storage, then we need to talk about storage classes, persistent volumes, and persistent volume claims, right? So the storage class is how the CSI is told to provision storage. In this case, I have my fast vSend flash, right? So that's going against the, I've named that fast so that I know at a glance which one that is. And then I actually also have a slow storage class as well that's actually going out to my old ZFS array via NFS. And basically, it just takes a parameter of the data store URL, which we'd get from the vSphere client, and then it allows you to provision storage against those storage classes. I have a number of takeaways today. This is one of the ones that I thought was the most important. I want to make sure that everybody out there using the new out of tree CPI to make sure that they use the right provisioner when they're building out those storage classes. You want to make sure that you use the csi.vsphere.vmware.com, because if you use the kubernetes.io one, you're going to get all sorts of strange, obscure error messages. When I was going through this, I actually bumped into this quite a bit, and I had error messages talking about the CPI not being configured. I knew it was because it was working and provisioning things just fine, but you want to make sure that you use the right storage class. So then obviously we have our storage classes handled. Now we need to talk about PVCs and persistent volumes. So a PVC is how you tell Kubernetes to actually, what type of access mode we want, how big it needs to be. It's kind of giving the information that the storage class needs in order to provision the disk. And then you also have a persistent volume. The persistent volume is what happens when you create that PVC and bind it. And then you also have the ability to create those ahead of time, right? So, how do we get these into our Kubernetes application? Well, that's where volumes come in. These volumes are, again, matched up against the PVC. Once we've got that PVC set up, as soon as I create this application, that volume is going to get created for me, and then it's going to get attached to that mount path inside of my container. So this is very similar to what I was doing in the past with bind mounts, only now we have volumes. Volumes are going to be pretty familiar with people who perhaps come up to speed with Docker recently, because Docker is already doing volumes. But again, this is basically saying, okay, /home/Minecraft/Enigmatica2/world, it's going to go out to my fast storage, and then that backup directory is going to go to my slow storage. So again, taking a look at the deployment in full, I fully realize that this is going to be an eye chart for everybody watching this on the stream. You don't actually need to know what all of the details are here, and I'm happy to share them with you elsewhere. I will have this whole thing up on a GitHub repo at some point in time. But again, what I'm doing here is I'm only having one replica because this is a crazy monolith that has read-write once storage. I cannot scale this out, all right? So I only have one replica because I absolutely cannot have more than one of these. It'll explode in a very fantastic way if two things try to write to the world store at the same time. And I've inadvertently found that out myself when I was using Docker and accidentally mounted the same thing twice. That'll fail catastrophically. I do define a lot of things via environment variables here. I think I'd like to move that towards a config map in the future. That's really the way that you're supposed to do things in Kubernetes, but I'll get there eventually, right? Famous last words, let's incur some tech debt. All right, so now I've got this Minecraft instance up and running, but I need to be able to access it because my Kubernetes network itself, the nodes themselves are not routable for me the way that I have everything defined. This was actually one of the first times I've dealt with on-prem Kubernetes where I wasn't dealing with a CSI that could give me load balancers. And I was trying to figure out how to do this. I didn't have NSXT yet. So I used MetalLB. MetalLB was surprisingly easy to configure. I started reading the documentation and it was talking about BGP and all these other things that made my head spin. And I was like, okay, no, that's too much. But it turns out the configuration was really easy. I just had to give it a couple of IPs. One of the other things you'll notice here is I'm using a kube control apply-f from a website. I wanted to make sure that I use this as an opportunity to get on a soapbox and tell people not to do that. You always want to make sure that you fetch those files first and examine them before you just go arbitrarily applying them to your cluster. So this is kind of a do as I say, not as I do kind of example here, but that is copy and pasted from the MetalLB documentation. So again, don't do that. So now we've got a load balancer. We just simply add a service of type load balancer to our manifest, and then MetalLB will assign an IP for it, and we're good to go. Then I use NAT for folks in the outside world to access it. So the next thing we have to talk about is Kubernetes requests and limits. So obviously with Kubernetes, these nodes are going to be multi-tenant. You're going to have a whole nother bunch of workloads on there. And we need to make sure that other things don't stomp on our applications, and we want to make sure that our application doesn't stomp on the others. So in this case, I'm utilizing a request, right? Because that's going to tell Kubernetes where to put this workload. If I have a bunch of 8 gig hosts, 8 gig worker nodes in my cluster, it's never going to get placed anywhere. So I have some big XL nodes in my environment. And again, this information is used to help understand where to put that workload and kind of provide some limits around that. If you actually exceed the memory limit, it's actually going to hard kill your pod. If you exceed the CPU limit, you're going to be throttled, right? But what we can do is we can actually utilize something like Dynatrace to make sure that we're looking out for that, so that we'll notice if that pod gets killed due to going out of memory. And then we'll also know if the CPU is throttling. I did try to set CPU limits here to more like 1.5 cores, which would be 1500M. And I found here, as you can see, that my CPU was still getting throttled almost half the time. So I did double my limit to give it 2 full cores. All right, so where are things now? Everything runs awesome in this new environment. You can see here I've got a nice little chart of the response time for the master tick thread. And that blue teal line on the bottom, coming in about 7.5 milliseconds, is where things are in my new environment. In my old environment, completely unloaded, was somewhere in the 15 to 17 millisecond range. So I've basically doubled or more improved the throughput of this environment simply by replatforming it. And the other interesting thing here is I've gone from bare metal to virtual machine based when I deploy TKG to vSphere, and it's still 3 times as fast. So I wanted to leave myself about a minute and a half here to talk about some of my closing thoughts. What I'm showing you here isn't necessarily the most advanced or the most complicated way to do this. This was something that I sort of crafted myself. There are some pretty advanced examples out there that can be tailored to specific mod packs. I've linked to one of those here. And then the other thing that I found was it was really hard to get hardware in the midst of a global pandemic. And from when I placed the order until I actually got my hardware was over 3 months. I had a CPU that was DOA, and it actually took me 6 weeks to get a new one because apparently there weren't any AMD EPIC CPUs in the entire United States. I had a melted CPU socket that's literally never happened to me before that actually took the CPU with it. So that was another couple of weeks to get that fixed. And I actually had bad, they were only 5 feet long, but I had bad Cat6 cables that actually caused vSAN to barf on me all the time. So all these kind of crazy things that happened to make this environment possible were really fascinating. But you can reach out to me at Twitter at Mike Villager, and perhaps I can actually provision you access to the environment. And definitely, if you have any questions, bring them up to me in the Q&A. And I believe I'm all done. Hand me over
All
to
right.
Nate. I'm
Thank you
at that
so much,
25-minute
Michael.
mark.
I really appreciate that. Ironically enough, I did run to fill up my water and noticed that my son was indeed engaging with Minecraft. And I did mention your presentation, Tim, but he decided to just play Minecraft instead. So I do apologize for that. All right, my friends, it is time to take a break. Go stretch your legs, top up your favorite beverage of choice. We're going to be back shortly with a wonderful presentation on testing from our friends at Liberty Mutual. So let's take a break. We'll be back in a few. Cheers.